Okay, so this is our walkthrough for a potential solution to the automatic equation generator problem which you were set. So in order to go about this, the first thing I'm going to do is open up our heads-up display because this is where everything is going to run. There's only two elements in the front end that I need. It's nice and straightforward. I need the actual text block which is going to print the equation. So I'm just going to first of all set that to a variable now that it's on the screen, and just call it math. That'll do. You can leave that as text block because it'll auto generate, or let's just leave that as let's try press to start. That's the first thing that the player will see when they open it up, and then we just need a button which will actually create it. Just pop that just there like so, and that's going to be our generator button. So I'll just call that, that's not quite right, but it's just generator is what we're after. There we go. And they're the only two elements that we need, so as long as these are both identified as variables, we're all good to go. And then with generator selected over here, we just need an on clicked, and we're going to keep these things nice and simple. All of the logic is all just going to go left to right from this particular point. Now before we start connecting things together, we need some variables. We're adding two different numbers together, so we need an integer 1 and an integer 2. There will be the two things that are added together or divided or multiplied or what have you. And then, as I alluded to there, we need an operator, something which is going to be the relationship between those two integers. So we'll start with the operator. These are all going to be integer values, so I'm just going to call this one int operator, and then create another variable. And this one is going to be our first value, and then another one, and this one's going to be our second value. So value 1, value 2, an integer operator. And I'm just going to drag these in and click set. You can also hold down Alt and it will do it automatically. If I held down Control, you can just see it just automatically generates as a get variable. If I hold down Alt, it's a set variable. But if you just don't press anything, then you have that little option before it opens up. So what we want to do is have a random integer in range. And because there are only 4 different operators we're choosing from, plus, minus, divide, and multiply, we need to go between the values of 0 and 3, so 0, 1, 2, 3. And that will then set a reference, an integer reference, to our operators. Then we need to do the same for setting the value of integer 1 and 2. So we'll just connect those together, and again the same thing, we need a random integer in range, but I'm going to change the values a little bit higher this time. So we'll set this as 0 to 100, and exactly the same for value 2. But I will set the minimum to 1. So again, the two numbers which we're adding together, at no point is it going to be adding, dividing, multiplying, or anything by 0, just to keep things a little bit more interesting. And once we've done that, we then need a way of kind of translating whatever our integer operator that we've selected actually into an effect that it has when it's creating our answer, which brings me to one last value that we need to create, which is the actual answer itself. So we'll create an answer value, and we'll have that but we'll have this one as I will explain a little bit later, we'll have this as a float variable. So if we drag this out and have set, but then what we need basically between these 2 points is a switch. So I'm going to drag the operator reference and then just type switch, and we'll get switch on integer, connect those in. And then because we've got those 4 different outcomes, 0 to 4, I'm just going to keep clicking add pin, and then we've got all these different options. So again, if it was 0, then it will trigger this one. If it was 1, it will trigger this one, and so on. And the idea is that it's just going to calculate the answer using a different operator depending on which one of those outcomes we have. Now, what we need now is a way of running those particular sums. So what we need again is reference to values 1 and 2 that we're always going to be adding or subtracting. And if we drag out from each one, we can do these one at a time. So if we just type in plus, we've got the plus, and then again just keep dragging out from value 1 for all of them to keep things simple, and subtract. Then and drag out and divide, and drag out and multiply. And then connect value 2 up into the space for each one. So for all the 4 different operators, we're connecting values 1 and 2 together. So you should have something which looks like that. And then we're going to translate that into the answer. Now the problem that we've actually got here, as you can see, is that these are not the same versions we've got, or they're not the same variable types. We've got integers here, and we've got floats there. So there needs to be some point where we can convert these. And actually the most appropriate place to do it will invalidate what I literally just did, which is here. So if I here get rid of that and then change that to, now we're not converting to a string, we're converting to a float. And copy paste, do the same here. And then that way we are making sure we're capturing the full detail as we generate our answer. So now we've got that in place. I just need to repeat that process that we did a moment ago. Add, subtract, divide, and multiply. And then again, plug the value 2 into each one of these, and now there's no need to convert anywhere else. So plus is going to be if 0 is triggered. If 1 is triggered, we're going to do a minus. If 2 is triggered, we're going to do a divide, and if 3 is triggered, we're going to do a multiply. So after that, I'll explain why we need a branch in a moment, but for the time being, I just want to connect everything else up. So no matter what process it used, what operator was selected, and in order to set the answer, once the answer is set, now all of the logic is all connecting back into one single stream. And again, in reasons that will become clear, we need a branch which will basically determine whether we loop all the way back to establishing the value of value 1 and 2 integers, or whether we say, right, we've got an answer which is within a particular constraint, particular range that we're as a developer we're happy with, and you can now print that to the actual screen. But we'll do that bit first of all. So if I get the actual text, if I remember what it was called, that was just called math, wasn't it? So get a reference to math, drag out here and type set text, and then it's the false that we're going to do. This is mainly, it makes the logic a little bit more complicated, but it basically means when we're looping back up here, it makes it a little bit neater, which I can show you now. So also ultimately that's what we're wanting to do, create this loop there. If I create a couple of extra points, then it tidies it up quite a lot. Obviously, if the false and true were the opposite way around, you'd get a crossover. It wouldn't be quite as neat and tidy, that's the method in my madness there. So that's going to loop back if this condition is true, and we'll get to what that condition is in a moment. But if that condition is true, it will keep the operator fixed, but it will then kind of loop through those two values until it gets an answer which satisfies this condition. So let's assume it satisfied that condition to be set to false, and it's not going to loop around anymore. Then we need to change this to a string. And the reason we're doing that is because that then gives us an ability to append a string, because we're just going to have one single line of text which is formed of various different components. So we need 5 components, so we keep adding pin until we've got A, B, C, D, and E. And as you can imagine, the first thing that we're going to need is value 1. We're going to need value 2, and we're also going to need the answer. So if we pop value 1 in first of all, and then we're going to need the actual operator. So we'll leave that one blank for a moment. Then we're going to need value 2. Then no matter what, we're always going to need an equals, and then we're going to need the answer. So putting all of those in is nice and straightforward. The tricky bit is getting the right icon, the right symbol, I should say, for plus, minus, divide, and multiply. Now, the best way to do that, again, there's probably several ways you can do that, but the way I've decided to do it is create another variable, and we are going to call this one just operator rather than int operator, and we will change this to a integer, But then over here in the variable type, we've got a drop down here. So it's set to a single variable type. We've got array, set, and map, and we want map. Now what map is going to do is kind of connect or determine what the output variable should be when the input variable is something particular, but they can be different variable types. So what that means is we can have our input variable as an integer, which means depending on whatever the value of our int operator variable is, that will output something that's not an integer, but that corresponds to that particular value. So if we change this, the output value, it would make most sense to have that as a string because that needs to go into here. So the input is an integer and the output is a string, and then we need to add these different elements. Now you'll notice if you keep clicking add element with this operator is 0, you get an error message. It doesn't let you do that. So we will get to 0 in a minute, but we have to do it last just to make things awkward. So if we look at the order in which we did things over here, 0 was going to be plus, so 1 is going to be the minus symbol, and then 2 was going to be the divide symbol, and then 3 was going to be the multiply symbol, and then 0 was going to be plus. So compile that, and then if we drag that into the space, pull out from there and just type find, and if we just make a little bit of space for this to all work, that can go into there like so. I can connect up there, and then get the integer operator. So again, that's been randomly selected right at the beginning. So before this loops around, it decides whether it's going to be a plus, a minus, a divide, or a multiply. And then based on that value, which is going to be fixed by that point, it will then look through this map and designate the correct operator symbol, and then that will be placed into here. So that should all match up and give us the output that we actually want. Now, the reason, the last little bit that I put in here is because if we just leave this exactly as it is, particularly with these random integers and ranges of large numbers, the issue that I had when I first designed this was if you were working with quite big numbers or numbers between 1 to 100, and you say got something which was like 95 plus 95, not particularly complicated math to do in your head, or 95 take away 92. The two values were quite large. It wasn't too difficult for you to add or subtract, but to multiply was pretty difficult. But on top of that, to divide was also extremely difficult and would also almost always require like decimal places. So to be able to do that sort of math in your head, in the instance what we're trying to do, it was not going to be something you could just quickly solve. So that was a constraint that was put on this from a design perspective. They had to be questions which could be solved in someone's head. They shouldn't need a calculator for it. So that's what this condition is for. It's to weed out any randomly generated equation that is likely to be too difficult to solve. So again, this is where design comes into this, because there's a number of different ways in which you could add constraints to the system, but these were the two ways that I decided to do it. So the first one was just to make sure that the answer didn't have a decimal place. So if it was a divide, for example, I wanted to make sure that it would never run a divide that wasn't didn't have a whole number as the answer. That would help make things a little bit simpler and easier for a user to be able to realistically answer without a calculator. So in order to do that, all I did was take the answer and round that up to the nearest whole number, and then basically compare the original value to the rounded value. And the idea then would be, if they are the same, then that's good. That means it's a whole number. But of course, the problem here is that this would set the branch value to true and would loop it round, and we don't want that. So what we actually need to do is drag that out, type equal, but we want a not equal. So if it's not equal and that is true, then it will loop. But if they are equal, which is what we want, then that will return a false, and that will go where we want it to go. The other thing that I wanted to do is to make sure that the answer just wasn't too large. If you were dealing with very large multiples, then you were going to have a number which is going to be really difficult to work with. And there were various different ways I thought about doing this, but I thought just querying the answer itself was a nice quick way of being able to limit how big and how complicated the multiply elements were going to be. So there's a couple of things here. So the first is that there's going to be not an and but an or. So if either of these two conditions, so I've obviously created the first one, but the second one that I'm going to create now is just to check if the answer is greater than or equal to 300. So just making sure that we're not dealing with any particularly massive numbers. And then if either of those two return a true value, so if it's greater than or equal to 300, or if it is not exactly the same as the value when it is rounded, so it's not a whole number. Just again, this is not particularly tidy at all. But if I'll try and neaten it up as best I can. That's terribly unneat. There is no particularly easy way to do this, I don't think. That's probably about as good as I'm going to make it. Okay, so within those things in place, what we should hopefully have now is a workable system where we can press start. It will generate a number. And that number should be clearly something we can just figure out in our own heads to double check that it's right. So 19 take away 14 is correct. 99 plus 61, 160. 60 divided by 5, 12. Yep, so all of these so far seem to be correct. I'm not great at doing divisions in my head, but broadly, if you give me a second, yep, that's correct as well. The only issue here, again, if I keep clicking them, they're always whole numbers, and the answer is still coming through with a decimal place, which is just a little bit messy, but again, that shouldn't be too difficult if we just take the answer here and round it up. And that is incredibly messy, so we shouldn't need to do all of this backwards and forwarding. We should just get rid of those two elements there, take the rounded variable, and just place it there. Compile and try that, press start. And now again, our answers still look correct. Yeah, minus 72. And again, for the most part, I mean, you could trial my particular design by infinitely clicking it and just seeing how long it takes before you get a question which really does kind of fall outside the remit of being something which most people would be able to solve in their own heads. But so far, there's nothing which is returning a false value, and there's nothing which seems to be falling out of our broader remit of something which could be relatively easily solvable in someone's own head. Okay, and that's that.